It's time to resume. Please return to your seats. We'd now like to start the final session. And I'll be moderator of this session. I'm Hamana from the Secretariat. In this session, companies will make presentations on the theme of introduction of the latest technologies for environmental management and services and technologies that contribute to the development in developing countries. The companies will introduce their technologies and services in the field of environmental management. Each company will have 10 minutes for their presentation and Q&A. When the 10 minutes is up, we will have to move on to the next company's presentation. The order of the presentation will be Shabondama Soap Company Limited, 2. HORIBA Limited, 3. JFE Engineering Corporation, 4. AC Biode Corporation, 5. NAKADAI Holdings Inc., and 6. TOYOKOSHO Corporation. Amongst them, NAKADAI Holdings and TOYOKOSHO will make their presentations online. So I call upon the first company, Shabondama Soap Company, to make the presentation, please. Tsuchida from Shabondama Soap. Thank you for inviting us today. I'd like to talk about the function and effectiveness of environmentally friendly soap-based Class A fire extinguishing foam, which is being touted as a potential game changer for global warming, as reported in Euronews and other outlets. Next. First, I'll introduce the history of environmental measures in Kita-Kyushu City, where our head office is located. Kita-Kyushu City has developed as one of the leading industrial cities in Japan since the establishment of the Yawata Steelworks in 1901. Rapid industrial development, however, has been accompanied by enormous pollution, including air pollution. Those that were the first to take action against pollution were the citizens, including the women's associations. Such action led to a concerted effort by citizens, companies, and the government to reduce air and water pollutants. And through that effort, the city was successful in overcoming pollution. Based on this experience, the citizens of Kita-Kyushu, including companies like ours, are working together to make Kita-Kyushu a model city for decarbonization in Asia. Various initiatives are being undertaken. We also want to take the environmental technologies and know-how that we developed to overseas to support the resolution of issues such as decarbonization and contribute to the achievement of the SDGs around the world. And one of these activities is the forest and the peat fire control using soap-based fire extinguishing foams, which I will now explain. Our company's philosophy is to protect healthy body and clean water. Founded in 1910 in what is now Wakamatsu-ku, Kita-Kyushu, Fukuoka Prefecture, this year marks the 113th year since founding. The head office is still in Wakamatsu, Kita-Kyushu City, with a branch office in Minato Ward, Tokyo. Our main products are additive-free household products such as soap, shampoo, and laundry soap. Next. Additive-free soaps of natural origin are, firstly, 100% biodegradable. Secondly, it has low toxicity to aquatic organisms and plants. And the key feature is that it is hypoallergenic to the human skin. We took the know-how gained from our consistent focus on the creation of products that are friendly to people and the environment, and developed the soap-based firefighting foam. So first I explain the background to the development of this. The main impetus was the Hanshin Awaji earthquake of January 17, 1995. This earthquake destroyed water pipes and fire prevention tanks and other infrastructure, and many fire brigades experienced the tragic experience of running out of water to extinguish fires. Incidentally, I was one of them. In response to this, since 1999, the Kitakyushu Fire Department and others have been researching ways to extinguish fires with less water using fire extinguishing foams. However, it was found that chemically synthesized foams are very environmentally hazardous and have a negative impact not only on people but also on vegetation by seeping into the groundwater. So our company, as I explained, we've consistently produced environmentally friendly products, and we were asked to develop a new fire extinguishing agent based on soap. We started development in 2001, and with the support of the national government and City University of Kitakyushu, we went through 7 years of iterative research and demonstration, culminating in the completion of a soap-based foam with world-leading environmental performance in 2007. Soap-based firefighting foam has 3 main characteristics. First is that they are highly effective in extinguishing fires by reducing the surface tension of water, increasing its penetrability, and lowering the temperature of burning materials. The second is a feature unique to soap-based agents. The foam decomposes after extinguishing the fire without staying in place indefinitely. And thirdly, it is environmentally friendly, which is of paramount importance today. The reasons for the high firefighting performance are: first, the surface tension of water is reduced by the extinguishing agent, and increasing the wettability. That increases the wettability, so the agent is not bounced off the burning material easily, and simultaneously, by increasing its penetrating power, it efficiently removes heat and energy to reignite the fire. The foam rapidly defoams after application by the soap combining with minerals in the ground and returns to nature. This picture shows a comparison to show at a glance the difference with chemically synthesized foams. The soap-based foam disappears after just 10 minutes, whereas the synthesized one hardly disappears. The good defoaming allows fast and safe cleanup and damage assessment after fire, so it also reduces the total cost. In addition to the fire extinguishing performance and good defoaming, the most important thing we have considered is the environmental friendliness, which, as I explained at the outset, has been a focus of the whole city of Kitakyushu. The main features include low toxicity to aquatic organisms, biodegradability so that the ingredients do not remain in the natural world, and no effect on plant growth. Next, this table shows At what concentrations of soap-based and synthetic fire extinguishing agents mixed with distilled and tap water kills half of green paramecium? This is experimental data from the University of Kita-Kyushu. It shows soap-based agents to be about 63 times less ecotoxic than some synthetic foams and about 10 times less toxic than the best performing synthetic foam. This photo shows a model biotope experiment in which 3 containers were prepared, reproducing natural vegetation including water and water plants. One had water only, one we added soap-based foam, and the third we added synthetic foam. They were left in nature for 7 months. The container with the synthetic foam had no vegetation whatsoever. They were all gone, while the container with the soap-based foam showed almost the same vegetation as the water-only container. This graph shows how much the components of the extinguishing agent break down without staying in the environment. Soap-based agents are almost 90% degraded by day 3, and after day 4, they are 100% decomposed and completely returns to nature. Synthetic agents were all found to decompose to only 80% and remain in nature after a number of days. What this photo shows is a part of a demonstration project to combat peat fires in Indonesia. Vegetation was burned under the same conditions, and the comparison was made 10 months later between fire extinguishing with water alone and with a soap-based foam. It's shown that grass and trees sprouted, exceeding the original vegetation, demonstrating that the soap-based foam had no effect on vegetation. This photo shows a demonstration project currently underway by Kita-Kyushu City and Chiang Mai Province of Thailand, aiming to decarbonize the country by suppressing forest fires at an early stage. Actual fires were replicated, verifying the efficiency of fire suppression using soap-based foams and assessing the impact on vegetation. This picture shows an actual case where soap-based firefighting foams were used in a forest fire in Kita-Kyushu City in 2018. A mixture of 1% soap-based extinguishing agent to water was sprayed by a firefighting helicopter. Approximately 17 hectares were burnt, but the fire was extinguished in just 2 hours without causing any major damage. In a previous forest fire of similar scale, firefighters extinguished the fire using only water, but more water was required and it took longer to extinguish the fire. Although simple comparisons cannot be made because the conditions were not exactly the same, the amount of water required was 1.7 times greater, the time taken was 1.5 times greater, and the area burned was approximately twice as large than when soap foam was used. In addition, there was feedback from the pilot that they could efficiently extinguish the fire because they can visually check from the air where the foam had been applied. Next, as an example of use other than actual fires, here's an example of use in securing safety during field burning. In Hiraodai, a limestone plateau in Kita-Kyushu City, in order to prevent forest fires damaging houses and crops and to ensure the safety of tourists, the local residents cooperate in burning an area of approximately 340 hectares in February and March every year. It's been planned for February this year as well. 340 hectares is equivalent to the area of about 380 football fields. The Kitakyushu Fire Department provides support by spraying soap-based firefighting agents around the perimeter of the area to be burned, in order to prevent the unintentional spread of fire. As I've explained, soap-based fire extinguishing agents, which combine fire extinguishing performance, environmental performance, and good defoaming, are now attracting attention as a concrete and effective countermeasure for forest fires, which is an urgent issue worldwide. Soap-based firefighting foams have been introduced in various countries, mainly due to their excellent environmental performance. And in several countries, they have moved from demonstration stage to practical use. We hope that your country will make use of this for the protection of forests and the environment, and we look forward to cooperating with you in reducing carbon emissions and protecting the global environment. That concludes my talk. Thank you very much.
Thank you, Mr. Tsuchida. Next is from HORIBA Limited. Mr. Kobayashi is the speaker. Hello, my name is Kobayashi from HORIBA Limited. Thank you very much for giving me this opportunity. We have measurement technology, but today I would like to introduce some of the measurement technologies that contribute to the carbon neutral society. We are a Kyoto-based manufacturer of analyzer and measuring instruments established back in 1945. Among our approximately 8,000 employees, more than 60% are foreign nationals and more than 70% of our sales are from overseas. Company's motto is joy and fun. Employees can find their work rewarding and make their days off at the company where they spend most of their time interesting and enjoyable. And this slide shows the outline of our business domains. Since we are mainly engaged in B2B business, our products and services are rarely seen directly by people in their daily lives, but they support people's daily lives everywhere based on measurement technologies. HORIBA has 5 distinctive core technologies: gas flow control, infrared measurement, spectroscopic analysis, particle size distribution measurement, and electrochemical analysis. We apply these technologies to our automotive, environmental, medical, scientific, and semiconductor businesses, and conduct businesses based on keyword of measurement. To achieve a carbon neutral society, it's important to avoid emission, capture carbon dioxide, and utilize hydrogen. These 3 are key actions. HORIBA is focusing on circulation of hydrogen, water, and the CO2 through the 4 technologies shown here: analysis of materials, physical properties, measurement of performance, monitoring of industrial process, and optimization of the system. Here's one example. The main part of this process is the synthesis of hydrogen and CO2 to produce fuel. From a carbon neutral point of view, the hydrogen used in this process must be green or purple hydrogen, which does not emit carbon dioxide during production, or blue hydrogen after carbon capture. CO2 must be recaptured from the emissions of the combustion process. This process creates a circular cycle in which CO2 is trapped and not emitted outside. Throughout this conversion process, HORIBA's scientific analysis and pH meter, gas analyzer, and gas monitor can contribute to the technological development and energy production toward carbon neutrality. Recently, use of hydrogen is becoming important. This diagram shows applications HORIBA can propose for the production, storage, and use of hydrogen. When producing hydrogen, measuring the concentration of impurities in hydrogen during the production process can lead to a reduction in hydrogen production costs. While many new materials are being developed for the use of hydrogen in fuel cell vehicles and household fuel cell, HORIBA's scientific analysis equipment is used for these purposes, including systems for fuel cell evaluation, our analysis equipment used in diverse fields of hydrogen. Let me touch upon the measurement needs for CO2 recovery. In the US, Section 45Q was introduced in August last year, which is a substantial tax credit system for CO2 recovery and storage, expected to invigorate the CO2 recovery market. As I mentioned earlier, the presence of overseas offices around the world should help HORIBA access the up-to-date CO2 recovery market information. In CCS plants that capture CO2, we have grasped the three latest customer requirements. One is the monitoring of CO2 concentration during the transmission through a pipeline or burying underground to calculate the amount of tax credit customers can receive. Next page onward, I will explain about the deterioration of amine solution used for CO2 recovery and the need for monitoring impurity concentration during CO2 recovery. Amine solution is used to recover a large amount of CO2. Amine solution reacts with CO2 at low temperature in the absorption tank and releases CO2 after high temperature reaction in the regeneration tank. The process is repeated to recover more CO2. Our gas analyzers and liquid analyzers are used in these types of plants. Gas analyzers are used in front of the absorption tanks, as well as inside. Amine solution tend to deteriorate due to repeated cooling and heating processes. This is an excerpt from an academic paper that measured the amine solution by Raman measurement. It shows the relationship between the thermal deterioration of amine and the recovery of CO, contributing to the reduction of CO2 recovery cost. This is a case study of CO2 impurity measurement using our proprietary RLAM technology. By using this RLAM technology, we can detect certain peaks that were difficult to do with the conventional infrared absorption measurement principle, thus reducing the influence of the base gas while performing more accurate measurement. In addition, the device is capable of wet sampling, where the gas in the pretreatment section and the analysis section is heated and aspirated so that the target can be measured without the dehumidification, even if it contains moisture. Those low concentration substance can be measured for the better management of CO2. Well, as I said, in my company, through measurement technologies, we are trying to contribute to the carbon neutral society for renewable energy and a new material development and gas measurement for CO2 recovery and gas measurement for CO2 recycling. Our gas and chemicals measurement systems are instrumental for all of these four areas. Thank you very much for giving me this opportunity to present here. Thank you.
Thank you very much. We still have a little time, so if there are any additional questions or any other descriptions that you would like to make here, if not, we can go to the next session. Thank you very much, Kobayashi-san. Next, I'd like to invite JFE Engineering. Mr. Takahashi, please. I will be presenting in English, so if necessary, please listen to the Japanese on the translators.
Good afternoon. My name is Takahashi from JP Engineering Corporation. It's a very great honor to make this presentation about some waste management solution for the some carbon neutrality and also the circular economy. JP Engineering is engineering business arm of JP Group. The JP Group is one of the largest corporate groups in Japan. JP Engineering is doing some various types of some infrastructure business, such as the environment, some energy facilities, or some various types of some infrastructure, kind of some bridges, and also the recycling business in this global market. Let me start talk about some waste issues. These photos, is it a good situation? Of course, answer is no. The open dumping site, such kind of some photos, the open dumping site causes the fires, toxics, bad odors, and many pests. The huge emission of methane gas at these kinds of open dumping site is considered one of the factors of global warming. And also the urbanization is making it difficult to secure new land for disposal site. This is a very worrying situation for the residents and communities. Please compare this picture with the previous one. It is a very common situation in large cities in Japan. Right next to the residential area, a waste-to-energy incineration plant has been built and is in operation. This is waste-to-energy incineration plant built by JP Engineering Corporation in Tokyo. How is it possible to build such kind of plant? Because JFE's advanced technology can minimize the emission of dioxins and also the other harmful substances, and also electricity or hot water supplied to the some residents nearby from this very safe and secure plant. And also, since this plant is very close to the source of emissions, so it not only reduces transportation costs, but also reduces dust, odor, and noise during waste transportation. We JP Engineering have a very many global track records of the waste-to-energy incineration plant, not only in Japan, but also in Asian countries and European countries as well. From this kind of some track record, I'd like to introduce our JP Engineering very latest case. This is the waste-to-energy project in Bac Ninh province in Vietnam country. This project, which is being launched with financial support from IFC and JCM subsidy program by the Ministry of Environment Japan, and it will process 500 tons of municipal and industrial solid waste per day, and it reduces the CO2 emissions by more than 40,000 tons per year with its 10 megawatt power generation capacity. This is a very simple illustration of JP Engineering's advanced waste energy technologies. this very unique hyper-stoker system is developed by JFE Engineering Corporation, of course. And also it achieves complete combustion in this incinerator. And thereby, it reduces the generation of toxic items, such as dioxins and NOx. So, again, waste-to-energy incineration project is the project that achieves a variety of benefit for residents. And also, we would like to mention that the hygienic treatment by waste-to-energy incineration system also can drastically reduce the incidence of waste-derived diseases. And also, installation of waste-to-energy plant avoids the emissions of methane associated with disposed organic waste in a dumping site. And the electricity that generated by the waste-to-energy incineration system, it displaces electricity from a grid which is generated using fossil fuels. And then for most appropriate waste management, in addition to the 3 R's, energy recovery at the waste energy plant and proper dumping or some proper landfill, so these 2 additional items must also be carefully considered if we are considering about some circular economy for your country, for your residents. As I explained, because of these kinds of multi-benefit by the waste energy incineration project, so waste energy the technology is also clearly recognized. It would also contribute the various SDGs for the peoples. Not only for the such kind number 3, number 11, but also, for example, number 9 or some number 12 goals, if we are thinking about marine plastic waste issue, it is also very good for SDG number 14. So JFE is just for the Earth. So if you're reading only big character just for the Earth, you kindly find our company name, JFE. So our mission, JFE's mission, is to create a safe and secure society to strongly support people's lives and to pass this on to the future generation. So this is end of my presentation. Thank you very much.
Thank you.
高橋様ありがとうございました
We have about 1 minute
まだあ
left.
と1分
Do
ほ
you
ど
have
ございま
anything
す
to
が、
add
何か
or
ご
other
説明
questions?
であったり、ご質問等ございますでしょうか。
Okay, thank you very much, participants. So if you have some questions or queries for my presentation or some for our company's technology, please feel free to ask. Please feel free to email to me. Maybe so the event secretariat can share the information. So please free to ask. Thank you very much.
高橋
Thank you,
様、
Mr.
ご発
Takahashi.
表ありがとうございました。では続きまして、
from AC
AC バイオード
Biode,
様より、
Mr.
久
Kubo,
保様、
please.
ご発表の方お願いいたします。
こんにちは。
Hello,
英語で私も
maybe
説明
explain
さ
in English as well. So my name is Tadashi Kubo from AC Biode. So AC Biode is a clean tech startup. We are based in Kyoto, in Tokyo, Luxembourg in Europe, as well as in the UK. And we are developing a new technology to recycle ash or waste, catalyst for plastic chemical recycling, as well as a battery system for mobility and energy storage as well. So this time, this is to upcycle ash or mineral waste into adsorbent. And we are cooperating with the Seon Corporation in Japan as well. So ash or waste is one of the biggest problems, mainly from biomass power plants, coal-fired power plants, municipality waste incineration, paper facilities, and also sewage sludge incinerators, as well as from mining waste. And it costs quite a lot of money. It 100,000 or millions of euros every year just to dispose these waste, because they include heavy metals, and also it's not easy to handle with as well. So mainly ash right now go to landfills or mix with asphalt or concrete for construction materials, but which is a bit lower value than what it should be. So we upcycle this waste into adsorbent in powder form, as you can see here. So this powder can be used as adsorbent, such as filters to capture CO2, methane, and also for soil improvement, water treatment, and also capture nuclear waste such as cesium. We have already commercialized and selling these products mainly in Japan and China right now, and want to expand this business in different countries. So here's one of the examples that it captures CO2. It is equivalent to zeolite, which is already in the market, and we are the only one in the market that is upcycled from the waste. So this is how our products look like. It captures not only physically, but also chemically through ion exchange structure, so that we can expand or improve adsorption capability as well. So there are existing products. It's called activated carbon, or kaseta in Japanese, and zeolite. So compared with existing products, we are as I mentioned, we are the only one we recycle from the waste. Production costs are cheaper, and the capability of adsorption is also higher as well. We need to build a recycling facility just next to the ash generation site, such as power plant or incineration facilities. And this is the general line we need to build. And this is the actual process we built in Taiwan. With Seon Corporation in Japan, we have built 2 facilities successfully. One in Japan from coal ash, and the other in Taiwan from biomass power generation in Taiwan. And right now we are getting around 12 contracts, such as in Kazakhstan, we got a contract in Thailand, Australia, Austria, Italy, and UK, as well as we are having one project in Bangladesh to recycle coal waste. So just to summarize, as far as we know, we are the only one that are recycling ash into adsorbent and have already commercialized into the market, as well as we secure some know-how, recipe, and a patent on this. How we do business is that we don't make machines, we don't build facilities themselves, but we provide engineering services to the owners of ash generation or waste. So for example, energy companies or paper companies. the market itself is growing steadily every around 3.4% for each absorbent market. So we want to tackle a couple of the market shares within the big absorbent market. Right now, our startup is still young, only 3 years old. We have now 10 members, mainly on engineering, the chemists and mechanical engineering, as well as chemical engineers. And we have raised funding from venture capital within the European Union. It's called EIT Inno Energy. And also we have just raised last year from Genesis Ventures, which is a venture capital in Japan. So that's it for now. So if you have any questions, either in English or Japanese, just please feel free to reach out to me. Here's my email address. And also, you can ask me any questions. I think we.
Thank you, Mr. Kubo. We have still 3 more minutes. If there is any additional explanation or if there are questions, please. No questions? Okay, thank you for the presentation.
Next speaker is from Nakadai Holdings. Fukuzaki-san, please. Yes, thank you. I will share my slides. Can you see my slides? Yes, we can see them. Okay, let me start my presentation. Is that okay? Yes, please. Thank you. Then I'm from Nakadai Holdings Company Limited. My name is Fukuzaki. Thank you very much for giving us this opportunity. Our group is not operating overseas. So I'd like to talk about our recycling business in Japan. Today, these are the 4 topics that I would like to cover. There are many slides. So due to the limitation of time, I may skip some of the pages. First, company name, Nakadai Holdings, and we have Nakadai Co. Ltd. and a Monofactory Co. Ltd. So these 3 constitute the Nakadai Group. The headquarters are located in Tokyo, and we have the incinerator plant in Gunma Prefecture. Overall, for the group, we have 80 employees. It's a small company. With these 3 entities, we are conducting waste management and the consulting service, as well as the establishment of the new recycling process to help with the recycling society. So these are the philosophies and the purposes of each entity, but I will ask to skip this slide. The point is that we are supplementing and complementing each other to create a virtuous cycle. And our group is conducting the so-called remarketing business. It's not only recycling or reuse. So once waste is generated, the point is how to recycle it in society. And before something becomes waste, how we can make sure that it is recyclable. That's the perspective we are taking. Specifically, in terms of the amount of waste that we are handling, let me talk about some numbers. Our company is located in Gunma Prefecture, but Japanese waste management is a licensed industry, so it is strictly regulated by law. So we cannot unlimitedly expand the facilities. Therefore, for us, if we assemble a lot of waste, that would be good, but we can't do that. Therefore, we are focusing on the process and the needs and the demands of the people who generate waste and the people who want to utilize the waste. And there's about 60 tons of waste coming to the plant, and we do 99% of recycling. And we use large facilities and equipment, but we focus on the generation of new materials. Therefore, decomposition and cleaning is done by hand, manually. And our employees know once they touch something, they can tell exactly what material it is. So we have a highly skilled employees. It is not only recycling, we also do the reuse business. As you can see on the picture, we have office equipment like lockers, tables, and chairs. And we have a marketplace. Every week, 10-ton truck worth of used office equipment come. And then we have the open market and marketplace system. And like this, we use the manual work and in the sorting and selection of waste so that we can still retain the value of used equipment. And this is our facility. There are many visitors. In the summertime, there are lots of children coming to see the plant tour. So manual work is important, but we also deal with the general waste coming from the households. It is not only recycle, we use waste for other purposes. This shows material library. For each type of material we sort, and then with waste, you see that a very interesting set of materials available from waste. We are just putting together on the display, and then this makes a very interesting display. And then we are selling those raw materials as well. And the materials themselves we are displaying, but it's not only that. We are trying to prevent the generation of waste and creating the mechanism for collection and recycling process. We provide a consulting service. So when we say waste, if you mix different things, and then sometimes it is non-controllable and it is very difficult to put them back to the raw material. But before someone disposes of any equipment, and then if we take action, and then we can increase the chance of recyclability. That's why the process design is very important. This is the way we use some of the materials. For example, this is a pool or a toy playground for kids from the PET bottle cap. And also some of the materials are used for the tables and the furniture. And Kuma Kengo is a famous architect. He designed this equipment store front from the recycled wheels of bicycles. And next, I'd like to talk about turning waste into business purposes. And this shows plastic waste reduction efforts. You may be aware of this issue. In 2018, China banned imports of plastic waste. In the past, China was importing a lot of waste from Japan and other countries, and then, but they stopped importing those waste. So domestically, we have a lot of waste stagnating. We are trying to export to Southeast Asia, but there is more and more regulation for this waste. Therefore, because of this regulatory situation, it was shocking that the China banned import of this. And it was a big topic in our industry because suddenly the door is shut, and then suddenly we have to deal with all of the waste in Japan. And but the fact that we have to deal with the waste that we generated within Japan, well, this may sound absurd, but in fact, Japan didn't do that in the past. So we have to have a recycling system which does not rely on other companies, other countries. So if we don't do anything, and then people cannot dispose of waste anymore freely. For example, per month, 45-liter bag, maybe only 2 will be provided for each household, and then the households cannot dispose of things so freely. So rather than just selling, but recovering the waste and recycling from waste will be key critical questions for the country as well as for society as a whole. Having said that, the recycling system in Japan, well, it is not so easy as it may sound. But we have a new initiative together with Kyushu Electric Power Company called Circular Park Kyushu. And there are some pages I like to go through, but I won't go into the details. This is happening in Kagoshima City, Kyushu, in Satsuma Sendai City. Kyushu Electric Power has a thermal plant, and it is now suspended, so we are using the X plant. And we are trying to establish a recycling system, and together with other private sector companies, going beyond the industry boundaries. This is the exact location within Kagoshima, Kyushu. The green circle part shows the exact location of the plant. And this is an open innovation in order to realize that this location will become the center for such collaboration. Lastly, let me show you the flow of waste and how we can utilize this for education purposes for companies as well as for consumers. We let the people try and do the recycling by themselves, and also together with the university students in a group work, we try to segregate different waste into different resources through the workshop they experience. And the kids come to the facility, and then they are decomposing PCs, for example, to see what kind of materials are included. So Japan is trying to establish recycling business from now. So to the rest of the world, well, we have the common issue, the waste problem. So we would like to promote collaboration with other countries as well. That's all from myself. Thank you very much. Fukuzaki-san, thank you very much for your presentation.
Next, from TOYOKOSHO, I'd like to invite Mr. Ikuta. Yes. So my name is Ikuta from TOYOKOSHO. You know, there's a lot of technical material in the material that I submitted. So I'd like to maybe first start with introducing my company. So in 1989, April, we founded the company in the Nihonbashi area of Tokyo. And we actually started as a non-polluting detergent company, but after 1960s, 1996, after 1996, we decided to obtain a national license to focus on photochemicals and photocatalyst technology. So we went to the National Industrial Institute in Tsukuba. We cooperated with them and with NICE to do a lot of research. And in November 2022, we've been able to deliver our products to 243 locations, and that will be 513 machines. And right now, we've been able to process per hour 10 million square meters. And so let me go on to talk about our photocatalyst technology. This is called PCF, which is photocatalyst deodorizing equipment. And we have one that's like a saucer and the other one that's like a cylinder. So in Japan, China, Vietnam, Thailand, the patent has already been applied. And also for the cylindrical part, in China already we've been registered. Wakita-san, do you want to share your material? Yes, I'm sorry, I forgot that. I will do that right now. All right, excuse me for that. Yes, we have the material. We can see the material. I'm very sorry, I'm not used to this kind of technology. So again, the device is called PCF or photocatalyst deodorizer. The area is air pollution control. So it's a chemical decomposition technology. Scope of application will be facilities that would discharge VOCs, like catering centers and kitchens. So basically, facilities who face odor or where there are a lot of stringent odor regulations. And so the technology itself, well, we have titanium oxide. This is the photocatalyst. And basically, we have the shared type. And basically, our technology's focus is to decompose the source of odor. And I do talk about some characteristics in this document, but if I talk about the cylindrical type, in the past it was just a flat type, but by making it into a cylinder or column, we have now these 3D cell filters and cylindrical cartridges. So this really saves the space. And also, the deodorizing capacity has also been reinforced. So it may be a bit difficult to see here, but basically, if you look at the cylinder, it's a 5-layer structure on the very, so there's the grease filter on the outside, and then there's the activated carbon filter, and then there's the photocatalyst filter. And so it will be attached top to bottom. So that's 2, plus it's going to be positioned in parallel. So this is a 360 degrees device to absorb the odor to be decomposed. Oh, sorry, so that's a cross section. So that's 2 cylinders on top of each other. So you've got the layer 1 and layer 2. So it's connected, but you can actually collect maybe 3 or 4 of these cylinder devices. And then on the bottom, this is a cross section looking at the device from the top. So there are 6 cylindrical devices. And then because it's connected, we have 12 units here in this casing because they're like one's connected on top of each other. So you come out from the right, coming from the right, and then you go through the left. So as the atmosphere travels, the odor is absorbed and the titanium oxide does the decomposition. And the right one, we see the side picture. This is the casing diagram. So if you look at the left and the right-hand side of this casing, you can see how it will look. It might be a bit difficult to imagine, but this is what we filed in our patent submission. With regard to this deodorizing performance, according to our test data, and that's based in the Kanagawa Industrial Institute test method. And so acetaldehyde and toluene, all of that included, we have been able to achieve more than 90% of deodorizing performance. So from the design, we provide consulting to design the device. Some applications or examples. Basically in Japan, this is so that people can meet the offensive odor control law. And also, Japan and Taiwan and Korea and China and Thailand actually measure, and also maybe Vietnam very shortly, they have the same measure of odor according to these legal regulations. Now, where you will be set it up, you can set it up in various places, but I guess a shopping center will be the largest example of our application. If you go to these large shopping centers, they want to make sure that the odor from restaurants and kitchens don't seep through so much, leading to complaints. And then also, this device can be used in school kitchens, or maybe also in pharmaceutical research centers, or in hospitals, maybe wastewater treatment facilities, printing facilities, painting facilities. And in any case, wherever people have an issue with the odor, this technology can be applied. And the structure of our system, basically, we only use electricity, so there's really no motor or fans. So the fans will be provided by the facility owner. And then what we're going to do going forward, we're going to try to introduce remote monitoring. So temperature, pressure, odor, and leakage of electricity, all of that should be handled by sensors as we try to control the operation remotely. This would lead to reduction of maintenance cost as well. So that is what we are currently working on. And then this is the acetaldehyde removal performance. So decomposition of the odor. So the blue is the concentration of acetaldehyde. And then the red dots, this is the CO2 addition. So when you decompose organics, you need CO2 and water. And so if more of this, the organic materials turn into CO2, then you will be able to see how much of the decomposition took place. And then toluene and other methyl melicaptan, and other components can be measured, based on the ISO standards. So all of that can be measured. So Ikuta-san, I'm sorry, I think your time is coming up. So would you be able to wrap up now? Yes. So for detailed data on our side, we have a website at TOYOKOSHO, so please visit our site. There is also a translator provided. It can be translated into 11 languages. If you're also interested further, please do not hesitate to contact us. We would appreciate that very much. Thank you very much for your time today. Thank you, Ikuta-san. So with that, we have been able to get presentations from all of the companies participating today. Thank you very much to all of you for participating and making your presentations today. And with that, all of the programs under the green stage have been completed. From 4:50 Japan time, there's going to be a closing remark from JICA, the host, in the venue right next door, which is the Blue Stage venue. And the Blue Stage is now in their last session. So if it suits you, you may be able to move to the adjacent room. Also, if you're listening in on Zoom, you can change the connection and listen in on the Blue Stage. Eventos online exhibition will continue up until tomorrow, February 3rd. And we introduce many of the environmentally related technology from Japan, so please visit that. And the material used today and the recorded videos will be posted on Eventos. After organizing and editing, it's going to be disclosed and published on the JICA homepage. And when it does, we will let you know. For those of you in the venue, please return your interpretation receivers to the reception before you leave. Thank you very much for coming, and thank you very much for listening in.